Okay, listen. Here they have given if a line intersects the sides AB and AC. If a line intersects the sides AB and AC of a triangle ABC at D and D respectively and is parallel to BC, then prove that they are asking us to prove. So for this example one of chapter 6. First, what we have to do is we have to draw a triangle. We have to draw a triangle. In this triangle, what you have to do is, okay, we have to mark the sides because it is mentioned as the triangle ABC. So vertex are A, B, C, 3 vertex. Now, a line intersects the sides AB and AC at D and E. So there is a line we have to draw over here. This line is intersecting AB and AC at D. This is point D and this is point E. Okay, this is point E. So this is the line which is intersecting AB and AC at D and E, respectively. Now the condition is, the condition given here is not the condition, as well as this D is parallel to BC. What is given, ma? Given condition is D is parallel to which side, ma? BC. This is given. D is parallel to BC. Prove that. What you have to prove is to prove. We have to write like this to prove. To prove AD by AB. AD by AB is equal to AE by AC. This is what we have to prove. Okay, please write now. Please write up to this step.
Finish, sir.
Finished, huh? Okay. Now listen. Now tell me, since this line is drawn parallel to BC, where BC is one of the side of a triangle, therefore, according to Thales theorem, okay, we know that if a line is drawn parallel to one side of a triangle, then that line will divide the other two sides in the same ratio. You know that, right? That theorem is called as Thales theorem. Yes or no?
Yes, sir.
Therefore, using Thales theorem, because it is given that D is parallel to BC, therefore we can apply Thales theorem. Therefore, since D is parallel to BC, we can write AD by DB. Okay, AD by DB. Because this point D divides the side AB into two parts, that is AD and DB. So the ratio of AD and DB is equal to, and here this line will divide, this line is intersecting at point E. Now AE by AC. This is the two parts. So AD by DB is equal to AE by EC. So this is because of which theorem we are writing this? By
BPT.
By Thales theorem. By Thales theorem. Okay, please write. Finished? Now listen carefully. Next step. Now, since it is given in the question that the line, okay, is parallel to BC, that is one side of a triangle. Therefore, the line divides the other two sides in the same ratio because of Thales theorem. So I have written the Thales theorem here. Okay, use the Thales theorem here. After writing the Thales theorem, what I'm going to do is I'm going to take reciprocal on both sides. What I'm going to take here? Please all of you write the step. What step you have to take now? Taking reciprocal on both sides. Please write this. In book they have not written this. You can write, okay, taking reciprocal on both sides. So when we take reciprocal on both sides, AD by DB will become what? This AD in the numerator comes to the denominator, and this DB in the denominator will go to the numerator. So what we'll get? DB by AD. Yes or no? Which is equal to, this EC will go to the numerator and this AE will come to the denominator. So it is equal to EC by AE. Are you able to understand this? We are just taking reciprocal. Okay.
Yes, sir.
Now, so next what we have to do is, this is an equation, right? In an equation, we can take reciprocal on both sides. Okay, then there is no problem. Okay. Again, in the next step, what I'm going to do is I'm going to add 1 to both the sides. There will be no change in the equality, because whenever you are adding a same number in both the sides, the equation, okay, will not be, what to say, will not get any change. The equality will not be disturbed. So for that, we are adding 1 on both the sides. Next step, what we are doing here, adding 1 on both sides. It is like a equation is, imagine equation like a balancing machine. That is why in olden days they will use, right? Nowadays they are using electronic machine to measure the weight. But in olden days they will use instrument, right? Have you seen ma in the shops?
Yes, sir.
Okay, so it is
Yes,
like
sir.
that measuring. Okay, that is weighing balance. So weighing balance, in that both the sides, if you are keeping the same weight, it will be in a balanced state. That will be in a balanced state. But if one side you are keeping one particular weight, means like you are adding some weight, and the same weight you are adding in the other side also, again that will be in the balanced state. Similarly, in an equation, if you are adding a number or subtracting a number on both the sides, same number on both the sides, this equal sign will not get changed. Okay, therefore adding 1 on both the sides. Now what we'll get is, the left side become, already left side we have dB by AD. You have to add 1. So it will become dB by AD plus 1, which is equal to EC by AE plus 1. Okay, va? Shall I proceed to the next step, ma?
Yes, sir.
Okay, next step. Now we have to take LCM. Since there is no denominator over here, we have to just do cross multiplication. So what we'll get is dB plus this AD into 1 is AD. Anything into 1 is the same will come, right? AD into 1 is AD. Whole divided by this AD will be the denominator, which is equal to, here EC is there, EC, and plus this, plus we have to put here, and this AE into 1 is AE. AE into 1 is AE. Whole divided by this AE will be coming in the denominator. Whole divided by AE, which implies. Now next step. See here, what is dB plus AD? I'm going to show the figure now. See here, what is in the numerator? dB plus AD. See the figure. This is dB. This is dB plus AD. So AD plus dB or dB plus AD. We can write it as AB. Instead of writing AD plus dB, we can write it as AB. Are you able to understand, ma?
Yes, sir.
Yes, sir.
Okay. Now, so AD plus dB or dB plus AD. So I'm going to replace this dB plus AD by AB. So what we are getting here is AB by, in the denominator what we have? AD, which is equal to, likewise, this EC plus AE. EC plus AE can be expressed as AC. See here, this is EC. From this point to this point, this is EC. From here, this point to here, this is AE. So AE plus EC or EC plus AE can be expressed as AC. Okay. Therefore, in the next step, right hand side, what I'm going to do is EC plus AE can be expressed as AC divided by AE. Now, what you have to do is, this is the final step. Now, again, we have to take reciprocal on both sides. Taking reciprocal on both the sides. Taking reciprocal on both the sides. If you take reciprocal on both the sides, what we'll get is AB by AD will become, this AD will go to the numerator and this AB will come to the denominator, which is equal to, here, this AE will go to the numerator and AC will come to the denominator. We'll get AE by AC. That's it. Please put the box. See here, this is what they asked us to prove. Prove that AD by AB is equal to AE by AC. Hence proved. That's it. Are you able to understand this?
Yes, sir. Much easier, sir.
Okay, you can write. If you have doubt, you can ask.
Excuse me, sir.
Yes, ma. Yes.
Sir, is taking reciprocal necessary?
Yes, reciprocal is necessary.
Uh,
Okay. Please write fast. If you have doubt, you can ask. Or else, you can ask some other question, ma. I'm ready to teach. Now, next, which question you want me to teach? Okay. Any other question you have doubt, you can ask now. Which question you want me to teach now?
Excuse me, sir.
Yes, ma.
How to find the cube root of any number?
How to find the cube root of any number? Huh?
Yes, sir.
Okay, I'll teach now. You know how to do the square root, right?
Yeah.
Okay. I'll teach. Shall I scroll down, ma?
Yes, sir.
Yes, sir.
Okay. So this is a general question. I will take an example. Okay. I'll do it here. Suppose they are asking you to find the cubic root of cubic. This is how they will represent, right? Cubic root of 1728. What we are going to find now? We are going to find the cubic root of which number? 1728. For square root, there is a method that is called as long division method. But for cubic root, what you have to do is to find the cubic root of any number. The meaning of cubic root, first I will explain. The cubic root of 1728 means what number is multiplied 3 times to get 1728. Able to understand now? For example, what is the cubic root of 8? Can anyone tell me?
2.
Very good, very good. 2. Because when you multiply 2 3 times, 2 into 2 into 2 will get 8. Therefore, cubic root of 8 is 2. Likewise, which number is multiplied thrice to get 1728? That is the question. So that is the meaning of cubic root of 1728. For finding the cubic root of 1728, what you have to do is, you have to prime factorize this 1728. Again, I repeat, for finding the cubic root of 1728, you should prime factorize that number, that is 1728. You all know what is prime factorization. You all know that, right? Prime factorization means writing a number as a product of its prime factors. So this is how you have to do, or else you can do factor tree method also. But I'm going to this method is simple for me, easy for me, so I'm going to use this method. So since this is a number which is ending with 8, therefore this is an even number. Any even number is divisible by the first prime number, that is 2. Now in 1 we cannot divide 2. We have to take the first 2 digit, that is 17. In 2 8s are 16. In 17 we have 8 times 2 will be there. So 2 8s are 16. In 17 16 goes off means the remainder is 1. We have to put that remainder 1 here. So now we have 12. In this 12 2 6 are 12. So here 8 is there. So now 2 4s are 8. This is how we have to do. Okay, you have to divide this 1728 by the first prime number 2 because it is an even number. This kind of division is called as bus stop method. Okay, usually we'll divide like this, right? 1728 will divide like this, 1728 divided by 2. So 2 8s are 16. Okay, 1. We have to bring down this 2. Now 12. Okay, now 12 in 2 6 are 12. 12 minus 12 is 0. Now we'll bring down this 8. Now in 8 we have 2 4s are 8. Like that you will do. Okay, this is normal division, long division. But here I have written 2 8s are 16. Now in 17 16 goes off means remaining is 1. You have to put it over here. Now 12 is there. 2 6 are 12. Now 12 minus 12 is 0. So we have 8. So 2 4s are 8. Okay, this is called as bus stop method. Listen now. Next, again here we got a what is it? This number is an even number. So again we can divide it by the prime number 2. Now 2 4s are 8. 2 3s are 6. 2 4s are 8. 2 3s are 6 and 2 2s are 4. 432. Again, this 432 is an even number because it is ending with 2. Now again dividing by 2. So 2 2s are 4. In 3, 2 1s are 2. In 3, 2 goes up, 2 1s are 2. 3 minus 2 is 1. We have to put this 1 here. Now it is 12. In 12, 2 6 are 12. Again, it is an even number ending with 6. Now we have to divide it by 2. What will get? In 2,
108.
listen, ma. See here. In 2, 2 1s are 2. In 1, we cannot divide by 2. So 1 is not divisible by 2. Therefore, we have to take the 16. But after the first digit, we are taking 2 digits together, means we have to put 1 0, which means 2 zeros are 0. 1 minus 0 is 1. Again, this 1 will come over here. That is 16. Now in 16, 8. So that is 2 into 108 is 216. Again, this 108 is divisible by 2 because it is also an even number. Now 2 5s are 10. I'll take these 2 digits. 2 5s are 10. Now 2 4s are 8. So 54. 2 into 54 is 108. Now again 2. 2 into 24. Okay, 54 is 2. Sorry, 54 divided by 2 is 2 2s are 4. 2 2s are 4. 5 minus 4 is 1. So 14 is there now. So 2 7s are 14. Now 27 is not an even number. So but 27 is divisible by 3 because 2 plus 7 is 9. If we add the digits of a number and we are getting a number which is a multiple of 3, then that number is divisible by 3. Because 2 plus 7 is 9. 9 is a multiple of 3. Therefore, this number is divisible by 3. 3 is a prime number, right? Now 3 9s are 27. Next 3 again 9. So 3 3s are 9. Last 3 1s are 3. At the end we have to get 1. Until that you have to do this division. Okay, only using prime numbers. See, we have used 2 and 3. 2 and 3 are prime numbers, right? Are able to have you all completed up to this one? Up to 3 1s are 3.
Yes, sir.
Yes. Now what you have to do is you have to express this one 1728. Listen carefully, which means 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3 into 3. That is called as, that will give you the answer 1728, 1728. So I'm going to write this 1728 by, therefore 1728 is equal to 2 is multiplied how many times? 6 times. 2 into 2 into 2 into 2 into 2 into 2 into, and last we have 3 times 3. 3 into 3 into 3. When you multiply this, all these numbers, prime numbers, you will get 1728. That is why this is called as prime factorization of 1728. Prime factorization means writing a number or expressing a number as a product of its prime factors. Product of only prime factors. This is called as prime factorization. After writing the prime factorization, since we are going to find the cubic root of 1728, we have to, okay, what is it, pair or not pair, we have to group, okay, 3 numbers, same 3 numbers into one group. So this 3 times 2 is there, here also 3 times 2 is there, here 3 times 3 is there. Okay, grouping the same numbers, okay, 3 times. Now in this group, because it is cubic root, right, that is why a same number with, okay, when it is multiplied 3 times, you have to form a group. So this is one group, here one group of 2s, and here one group of 3s. In every group we have to form, it should be having 3 numbers, not 3 numbers means one number 3 times. That is, here 2 is multiplied 3 times, here also 2 is multiplied 3 times, here 3 is multiplied 3 times. Now in this group, I have to take 1 2, and in this group I have to take 1 2, and in this group I have to take 1 3. Now multiply these 3 numbers. What will you get? 2 into 2 is 4, 4 into 3 is 12. Therefore, the cubic root of 1728 is 12. If you want, you can check. If you multiply 12 3 times, you will get 1728. Are you able to understand this, ma?
Yes, sir.
Yes, sir.
That's it.
Yes, sir.
In another way, I will explain this, ma. 1 minute. Listen carefully. Now, here I have formed a, okay, group of 2 multiplied 3 times. So 2 into 2 into 2, what is called as, this step I will write it over here. So 2 into 2 into 2 is, we can write it as 2 cube. Am I right or wrong? 2 into 2 into 2, 2 to the power 3 into this multiplication. Now again, 2 into 2 into 2, that is also 2 cube, into here 3 into 3 into 3. How to write this? 3 into 3 into 3.
3 cube.
3 cube. Now we have a power m into b power m into c power m. All the powers are same. Okay, these numbers are okay. See here the base. Here the base are same. There is no problem. But the powers are same, right? If the powers are same, you know this law of exponent, right? That says a power m into b power m. What will write? A into b the whole power m. This is for 2 bases, but here 3 is there. So what we can write here is the next step 2 into 2 into 3 the whole power 3, because all the powers are same, right? So we can write 2 into 2 into 3 the whole power 3. What is in the left hand side? We have cubic root of 1728. Cubic root of 17, sorry, not cubic root of 1728. We are this is the factorization of 1728. We got it as 2 into 2 into 3 the whole cube. This is equal to, now 2 into 2 is 4, 4 into 3 is 12. So that is 12 cube. Therefore, 1728 is equal to 12 cube. Are you able to understand now? Therefore, when 12 is multiplied 3 times, you will get 1728. Hence, the cubic root of 1728 is 12. Complicated, are you able to understand this? How to find the cubic root?
Yes, sir.
Okay. What we are doing here is, after finding the prime factorization of the given number, for this we are going to find the cubic root. We have to form a group of three same numbers. Likewise, here we have 3 groups. In all the 3 groups, we have we have 3 numbers which are same. Okay, 3 same numbers. So in this one group, we have to take 2, and this group we have to take 1, 2, and this group we have to take 1, 3. When we multiply these three numbers, you will get 12. That is the answer for cubic root of 1720. If you want me to teach the same with another example, I will teach, or else we can move on to the next one. Now, if you have any other doubt, you can ask.
Yes, sir. Move on, sir.
Yes, ma.
Move on, sir. Please.
I'm not able to hear you. You want?
No, I mean, sir. Move on to the sum, sir. Another,
1 minute.
sir. 1.2 question number.
1 minute. 1 minute. Okay, wa? This one.
Yes, sir. Done, sir.
Okay, ma. Done. Now, next which question, ma? 1 minute. One question asked. One question typed in the chat box. 1.2 question number 6. Wait a minute, I'll check that. 1.2 question number 6. Okay, anybody have any other doubt, you can ask now. One point of question number 6, I have already taught you, I think so, but I will teach one more time. Please erase this now. Written, okay. That yellow color. Okay, listen. So one student has a doubt in exercise 1.2 question number 6. Exercise 1.2 question number 6. I will teach that now. Okay. It is very simple question. Here they are asking, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Why these two numbers are composite? Listen, first I will write this. 7 into 11 into 13 into 13. It is not into here. 7 into 11 into 13 plus 13. Why this number is composite, they are asking. So for that, what I'm going to do is, in this number, see here, it has 2 numbers. This is one. We have to consider this as one single number because it is in multiplication. This is another term. So we have to first see whether this this 13 is common for both this, right? This first term and this second term. I'm going to take this 13 as common outside. If 13 is taken common outside, what will get? 7 into 11 will be the remaining 7 into 11 plus, since this 13 is taken outside, you have to put 1 over here. The meaning is 13 into 7 into 11 is 7 into 11 into 13 plus 13 into 1 is the same 13. Okay, we are taking this 13 common outside. Now what we get is 13 into 7 into 11, 77. 77 plus 1. 77 plus 1 is nothing but 78. Therefore, we got 13 into 78. Now listen carefully, ma. This given number, okay, this is the given number. This number is expressed as product of two numbers. And that too here, this is one prime number, that is 13 is prime number, but 78 is a composite number. We know that. It is an even number. All even numbers are composite, except 2. Because 2 is the only even prime number. Other than 2, okay, the numbers which are greater than 2, which means any 2-digit even number. Simply you can say any 2-digit even number are composite numbers. Now, or else in other words, what we can say is, if a number is expressed as a product of two numbers, if a number is expressed as a product of two numbers apart from 1, because 13 cannot be expressed as 1, 13 can be expressed as 1 and 13. No other way. We cannot express 13 as a product of any two numbers except 1. Only 13 can be expressed as 1 into 13 because 13 is a prime number. But here, this given number is expressed as 13 into 78. Hence, the given number is a composite number. Because they are asking us to find, okay, they are asking us to explain why this number is composite. Now, what you have to write is, since the number is expressed as a product of two numbers, okay, please write, since the given number is, after this step, you have to write like this. Since the given number is expressed as product of, since this number is expressed as, given number is expressed as product of two numbers, comma, or else we can product of two numbers, so it is a composite number. You can write like this. It is a composite number. Please write.
Finished, sure.
Finished, Amma. This is another method of expressing. Now, second subdivision, see here, another one number is also given, right? That is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Now, see, here also what I'm going to do is, this here also, see, here in this number, here have 5, here also 5. So I'm going to take this 5 as common outside, putting a bracket. Now the remaining is 7 into 6 into 4 into 3 into 2 into 1. 7 into 6 into 4 into 3 into 2 into 1. Plus this 5 is taken outside, right? So it becomes 1. In the place we have to put 1. Because the meaning of 5 is 5 into 1. Therefore, when we are taking this 5 common outside, in that place we have to put 1. Now what we'll get is, this is equal to 5 into, now 7 into 6 is 42. 7 6 are 42. 42 into 4. Okay, now 42 into 4 into 3 is 12. 12 into 2 is 24. 24 into 1 is 24. Now 42 into 24. What is 42 into 24? I'll write the answer, that is 1008. It is 1008 plus this 1. So what we get is 5 into 1008 plus 1, 9. 1 is 1009. 1008 plus 1 is 1009. Now see here also that given number is expressed as product of two numbers other than 1. In these two numbers there is no 1, both are other than 1, right? Therefore, if a number is expressed as product of two numbers, then that particular number is surely a composite number. Then that particular number is, sorry, ma, this particular number is surely a composite number. Are you able to understand this? The same step you have tried it over here.
Yes, sir.
Okay, that's it, ma. Any other question? No doubt. Okay, no
Exercise
problem.
2.3, sir.
Exercise
2.3,
2.3. 2.3, which question?
number 5.
Question number 5, Ama.
Yes, sir.
Give examples of polynomials p of x, g of x, q of x, and r of x, which satisfies the division algorithm. Right?
Yes, sir.
Okay, good. I'll teach. Now, next, all of you, okay, take exercise 2.3, ma. You can mute now. Take exercise 2.3. Exercise 2.3. Question number 5. In this, they are asking us to find, okay, they are asking us to give example. That's it. It is a simple example I will give. Okay, simple example. You all remember the division algorithm. Do you remember, ma, the division algorithm?
Yes, sir.
What is the division algorithm? Yeah, what is the division algorithm?
A equals to B into Q, Q into B plus R.
A is equal to B into Q plus R. Yes or no?
Q. Yes, sir.
Okay, very good. This is the division algorithm, which means, see here, this A is called as dividend. What is this A, ma? Dividend. And this B is the divisor. And this Q is
Question.
Quotient.
quotient.
Remainder.
QU. Okay, quotient, and R is the remainder. Which means dividend is equal to divisor into quotient. Dividend is equal to divisor into quotient plus remainder. Now, what we have to do is, this is for, okay, this division algorithm is true for numbers as well as polynomials also. Now, here they are asking us to use the division algorithm, okay, and find the value of p of x, q of x, g of x, p of x, g of x, q of x, and r of x. So here, listen, first we have to know what is p of x. P of x is nothing but dividend. What is p of x, ma? P of x is dividend. And what is g of x?
Divisor.
Divisor, very good. G of x is divisor. And what is q of x?
Quotient.
Quotient. It is a quotient. That is also a polynomial. Quotient. And what is r of x?
Remainder.
Remainder. Please write, ma. All of you write this. Okay, I'm going to tell you a shortcut. Using this shortcut, you can write any example for this particular question. Okay, you can write any example. Okay, I'm not going to give tell you to write this example. Okay, whenever it is asked in the exam. No, it is not like that. You can write your own example, but you have to use this. Okay, this small technique. Remember this technique, and you can use you can write your own example, whatever you want. Now, first question is for first subdivision. What they are asking is, for first subdivision, what they are asking is the degree of, listen carefully now, degree of, what is p of x? P of x is nothing but dividend. Degree of p of x is equal to, degree of p of x is equal to degree of which one? Q of x.
Q of x.
Okay, wa? Degree of p of x is equal to degree of q of x.
Q.
Now, what you have to do is, listen, whenever you are asked to write an example for the polynomials where the degree of p of x is equal to degree of q of x, remember, whenever the degree of p of x is dividend, p of x is dividend, and q of x is, okay, q of x is quotient. if you want to form a polynomial where the degree of dividend is equal to degree of quotient, means very simple thing is you can write a polynomial first, because we have to form, okay, we have to give example for p of x, q of x, g of x, everything, right? So first you can write a polynomial p of x of degree, listen carefully, of degree 2 or 3, it is up to you, but whatever degree you are forming, listen ma, whatever polynomial you are forming, make sure that all the coefficients, that is the coefficient of x square, because I'm going to form a quadratic cube, what is it, cube, this quadratic polynomial, x square plus the constant term, all these coefficients are multiple of any particular number. For example, it can be a multiple of 2, it can be multiple of 3, or it can be multiple of 4 or 5, or whatever it may be. I'm going to write it as 3 here. This is 5x square plus 10x plus 15. Is it easy to remember this p of x? It can be 5x square plus 10x plus 15, or if you want 2x square plus 4x plus 6. This is a simple method to remember this kind of sums. Now I have taken a polynomial p of x for the example. Now I'm going to take g of x. I'm going to write g of x. Now for this, what I'm going to do is, because we have to form a polynomial such that the degree of p of x and degree of g of x, q of x are same. If you want to form both the degrees, okay, two polynomials where the dividend as well as the quotient are having same degree, then surely the g of x means that is divisor should be a constant polynomial, and that constant polynomial I'm going to take it as 5, because here all the coefficients are multiples of 5. 5 ones are 5, 5 twos are 10, and 5 threes are 15. That is why I'm taking g of x as 5. Please write this. Are you able to understand this?
Yes, sir.
Yes, sir.
Now, since p of x is 5x, multiples, all the coefficients are multiple of 5, and g of x is a constant polynomial, that is 5. Now the quotient will be, listen, the quotient will be very simple. If you divide this by, if p of x is divided by 5, 5 by 5 will become 1. So it will become 1x square, plus 10 by 5 will become, what is 10 by 5? That is 2. So 2x. And plus what is 15 by 5?
3.
3. Now see here, in this example, the degree of p of x is square, that is 2. Highest power of the polynomial is degree, but degree is here 2. And what about the degree of q of x? That is also 2. Are you able to understand, ma? The degree here also, the degree is 2. And what about the remainder? What is the remainder? Name, tell me, what is the remainder for this particular example, ma? P of x, g of x, and q of x? The remainder is 0. Very good. Superb. Remainder is 0. So please remember like this. Okay. You can give an example like this for this particular question. Degree of p of x is equal to degree of q of x. Completed, Amma?
Yes, sir.
Okay, next. Now listen, ma. Next subdivision I'm going to teach. Shall I start? Second subdivision.
Yes, sir.
Okay. Okay. One more thing. Okay. Yeah. 1 minute. Next. Second subdivision is what they asked is degree of q of x is equal to degree of r of x. That is, the quotient and the remainder are having the same degree. Okay, quotient and remainder are having the same degree. For this, okay, first what we have to do is we have to write what is p of x, that is dividend. Okay, dividend I'm going to write, okay, like this. Even you can write whatever you want, but this is one simple example, that is x, without any, listen ma, without any coefficient, write a cubic polynomial. So x square plus x cube plus x square plus, after x square which term will come? X. After x the constant term is 1, because I'm considering all the denominators. Listen ma, I'm considering all the, all the coefficients of this particular x cube term, x square and s plus x and the constant, all are I'm considering it as 1. So like this, you can take a polynomial p of x for giving an example for degree of q of x, that is quotient, okay, as well as the remainder are having same degree, equal degree. For that, take p of x is equal to x cube plus x square plus x plus 1. Have you written this?
Yes, sir.
Okay. Now, when you divide this polynomial by g of x, that is another polynomial, that is g of x is dividend by a polynomial whose degree is 1 less than this degree. Here it is cubic polynomial. Now we can write a polynomial where the degree of degree is 2. So I can write it as x square minus 2 or plus 1. Yeah, whatever I want, I can write. Or minus 1 I'm going to write here. I'm writing x square minus 1 because this should be at least 1. The degree of this divisor should be less than the degree of the dividend. That is here 3, here it is 2. Like that you can take. This is an example. Okay, it's g of x. Now, if you divide these two, what we'll get is, if you divide these two, for this particular question, please write, okay, whatever I'm writing here, but no need to, okay, I will do it in the next class, because for this question, they are asking only the examples. Please write this example. In the next class, I will explain how to divide this two. Now here the quotient will be, when you divide this polynomial by x square minus 1, what we'll get is the quotient is x plus 1 will come, as well as the remainder will be 2x plus 2 will get. The remainder will be 2x plus 2. Now see here, just observe the quotient and the remainder. What is the degree of quotient, ma'am? What is the degree of quotient?
X plus 1. X plus 1.
No, I'm asking, I'm not asking what is the quotient. Instead, I'm asking what is the degree of this quotient?
1.
1, very good. And what about the degree of r of that is remainder, r of x?
1.
1. See, now this condition is satisfied, right? Degree of q of x is equal to degree of r of x. Okay, Mama?
Yes, sir.
Yes or no? Now, okay, for the third subdivision also, I will give an example in the next class. Okay, we don't have sufficient time. I will explain in the next class. But you can write the example. In the third subdivision, what they are asked us to do is give us give examples for which the degree of remainder, that is r of x, degree of remainder is 0. Degree of remainder is 0. The meaning of degree of remainder is 0 means you have to get the remainder as a constant polynomial. Have to get the remainder as constant polynomial. For that, what I'm going to give here is, that is third subdivision is r of x is equal to 0. R of x is equal to 0. For this, please write the dividend mark. Sorry, not dividend. Yeah, first dividend. P of x is equal to, please write this mark, x cube plus 2x square minus x minus 2. This is P of x, and g of x, that is divisor, that is equal to x square minus 1. X square minus 1, and q of x, which is equal to x plus 2. X plus 2, and here the r of x, that is r of x means remainder. We will get the remainder as 4. 4 is a constant number, right? It is a constant polynomial. For any constant polynomial, the degree is 0. You know why it is degree 0? Do you know, ma'am?
No.
No, you don't know. Listen. So 4 can be expressed as, listen, this is an extra. Okay, 4 can be expressed as 4 times x to the power 0. Because 4 can be expressed as 4 into 1. 4 and 4 into 1 both are same, right? 4 can be expressed as 4 into 1. Is it correct?
Yes, sir.
Yes. Now this 1 can be expressed as, we know a property that is in an exponent, anything to the power 0 is 1. Do you know that? Anything to the power 0 is 1?
Yes, sir.
I've already taught you, I think. Anything to the power 0 is 1. Therefore, I'm writing x to the power 0. This x is the variable. Now see here, what is the power of this variable x here? It is
0.
0. Therefore, this is called as polynomial of degree
0.
Therefore, the remainder is 4 means, therefore, any constant number is there means for any constant, the degree is 0. Are you able to understand how the constant is having degree 0?
Yes, sir.
Okay. Now, those who know how to divide a polynomial by another polynomial, please divide this cubic polynomial by this quadratic polynomial and check whether you are getting this quotient and this remainder. Okay. For those who don't know how to divide a polynomial by another polynomial, I will teach you in the next class. Okay, va? But write this answer. This is an 1 mark question. They are just asking an example. In another way method, okay, I will teach. In another shortcut also I will teach. Because we don't have sufficient time. That is why I'm just giving the example here. For the same example, we can write any number of any example you want, but you have to follow a technique to write these examples. I will teach you in the next class. Now you can complete this. Those who have completed, you can leave. Okay, you can continue. We will continue in the next class. That is on Monday. Completed, Amma?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, sir. Bye bye.
Bye, Ma. Bye, bye. Thank you.
Bye bye.
Thank you, sir. Bye.
Thank you, Ma.